Okay, today we're going to discuss finding the slopes and equations of perpendicular lines. So we have our title, perpendicular lines. We're going to date our notes. And first we need to define what perpendicular lines are. And perpendicular lines are two lines, just two, that lie on the same coordinate plane, just like we do with parallel lines, in the same XY plane, that intersect to form right angles. And remember, a right angle measures 90 degrees, so we're looking for that corner. And how we note that it is perpendicular or that we have right angles is with this red square right here. That means a right angle. So a horizontal line and a vertical line, when they intersect, they will always be perpendicular. That's why our walls intersect with our floors at corners. So we note that when I have a horizontal line and a vertical line and they intersect, that they intersect at a right angle. So therefore, this line is perpendicular to that line. Now, like with parallel lines, we're far more concerned with our slopes. So here's what we know about slopes of perpendicular lines. And this is the notation we use for perpendicular. It's an upside down T. So instead of writing it out all the time, we're just going to use this notation. So the slope of perpendicular lines, they must, when you multiply them together, their product must be -1. That's just the truth. Any textbook, that's what you're going to see. But that's how we prove that lines are perpendicular. Trying to find the slope that they're perpendicular to, we kind of have to do a little bit of a trick. So what if I use the same formula and I solve for M1? Since I have multiplication occurring, I'm going to divide both sides by M2. And we're going to notice that M1 equals -1 over M2. So really what we have here is we have a positive slope and a negative slope. So my signs are opposite. That's what opposite refers to, opposite signs. So we have an opposite, and then we've taken M over 1, because there's a little indivisible 1 underneath here, and we've just flipped it to get 1 over M, which is what we call the reciprocal. So we have the opposite reciprocal. That's how you find the slope of a perpendicular line, is you look for the opposite reciprocal. So go ahead and hit pause for if you need to write this down. I'm going to erase the board, and we're going to find perpendicular slopes. Whoops, wrong color. So perpendicular slopes, and again, I'm just going to use the notation because we can. Remember, we're looking for opposite reciprocal. So if my slope of my first line is -1 over 2, what must my perpendicular slope be? Well, we're going to take the opposite. So since this is negative, we're going to make it positive. And then we're going to take the reciprocal, which means we're going to flip it. So instead of being 1 over 2, it becomes 2 over 1. For number 2, what if I have that my first slope is 3/4? Well, then my perpendicular slope, since this is positive, this has to be negative. And then we're just going to flip them. So instead of 3 over 4, it's going to be 4 over 3. Okay, now here's the hard one, number 3. What if my slope is -2? Well, as you all know, we always put slopes in fractional form. So go ahead and write a 1 underneath this guy, so that when you have your perpendicular slope, well, we know we have to take the opposite sign, so this guy's positive, and that when I take the reciprocal, it's a lot easier to see that it really is 1/2. And then here's our last example. What if M1 is undefined? Well, what does that mean? That means that it has an undefined slope, so that means it's a vertical line. Well, we just learned from our graph that what's always perpendicular to a vertical line? A horizontal line. Horizontal lines and vertical lines are always perpendicular to each other. So therefore, my perpendicular slope must be a horizontal line. And what's the slope of a horizontal line? Well, we can walk on the line, so it has to be 0. So this is our special case. Whenever you have horizontal and vertical lines, you have to understand that you have undefined versus 0. So you have vertical and horizontal, that's the relationship. We just can't do the reciprocal. Okay, so let's do some examples. So we want to find the equation of a line that's perpendicular and it contains a certain point. And then we'll be done. So, finding equations of perpendicular lines. And again, I'm just going to use the shorthand. We want to put it in point slope form. Because chances are you're going to be given the slope and the point, or you're going to be given 2 points, and you can find the slope. And then we always want to try to remember to first step is to determine what that perpendicular slope is. So let's grab an example. What if I had a line that was 3x minus 2 and it went through point, the perpendicular line went through point 6, 4. Well, first we have to determine the slope of this line. So m1 is 3 over 1. We're always going to write it as a fraction. So therefore my perpendicular slope has to be the opposite. So I'm going to go from positive to negative, and then I'm going to take the reciprocal, which is 1 over 3. And then I have my point here, which is x1, y1. So we're just going to plug it into point slope, which is y minus y1 equals mx minus x1. So my equation of a line that is perpendicular to this guy, but contains this given point, is y minus 4 equals negative 1/3, because that's my perpendicular slope, x minus 6. Hopefully that made sense. If not, we'll do one more. Okay. Let's do, we have y, ooh, that's horrible x. Y equals negative 4/3 x minus 7, so that's our original equation of a line. And then we have a point that is 0, negative 3. So the first thing is to determine the slope of this line. So m1 is negative 4 over 3. So therefore my perpendicular slope, take the opposite, so negative to positive, and flip, 3 over 4. And now let's plug it into point slope, where this is x1 and y1. So I get y minus a negative 3, so I'm going to have to come back and simplify that. My perpendicular slope is 3 over 4, and I have x minus 0. So my final equation is y plus 3 equals 3 over 4, x minus 0. So now you found the equation of a line that is perpendicular to another line that contains a given point. So if you have any questions, circle them, let me know. If not, I'll see you tomorrow. Good luck.